To APAN. Welcome to the MANRS training session. My name is Yaqui. I'm from Iowa. I'm the chair of the MANRS training session. This is our fourth day at the APAN. We are happy to gather here. And please allow me to introduce our trainer, Varric. Varric is the head of network and system architecture for AARNet, the Australian agent. He has a background in various technical roles, ranging from system administration to network architecture across banking, defense, mining, and service providers. Please join me in welcome Varric.
Hi, everybody. Thank you very much for the introduction. So I'm going to be talking about MANRS. And obviously, being the fact that this is a room and a virtual presentation, it's going to be a little challenging to see if you have any questions. So please don't hesitate to reach out and get one of the people in the room to let me know that you want to speak or that you have a question that you would like to talk about. So firstly, I'm going to talk about what is MANRS. So MANRS itself is basically a, how do I put this? It is an initiative by a group of people which started out with the idea of how do we improve and uplift security across the internet in terms of how we actually secure the BGP sessions between entities. You might think of BGP as a bit of a trusted entity in terms of you can announce your routes and your neighbor will basically just accept them within reason to make sure that your routes are propagated and passed from one AS to the next AS to the next AS, and there's generally speaking a inherent trust chain there. But how do you know that those routes are actually valid? So one of the things that MANRS attempts to do is to try and promote some generic good policy in how you maintain your routes within the Internet Routing Registry, as well as how you contain your routes from a RPKPI, so route object authorization and validations. So there's a number of different aspects. There's a series of, how do I put it, policies that or recommendation actions that are in essence what is recommended for you to try and follow where possible to run through what is the expectation that you have on not only yourself, but on your partnered networks in regards to what you want to see come from your neighbors in terms of valid routes or invalid routes potentially. So with that, what I want to talk about is the individual actions. So there's a number of different actions that are under the process of MANRS. There are basically four main actions. They come down to filtering, coordination. Sorry, I've had a mental blank, and a couple of bits. So I'm just going to share, show something on the screen. Just bear with me 1 second, and then this will help just align where I'm up to. So I just had a computer problem, which is why I haven't actually started showing some slides. So let me put these up. So as I said, MANRS is important. And why is it important? Hopefully someone can see this, and just nod if you can see this, or raise a hand. Yes, okay, I've seen some hands raising. Thank you very much. So I'll talk about what MANRS is, and as I said, the various components. So as I mentioned, MANRS is about internet routing and the fact that its foundations have cracks, as we'll talk about with BGP leaks and hijacks. There are a number of different events that affect the routing system nationally and internationally and, well, globally. Some of these you would have seen, like, for example, when YouTube went off the air. And so, as I said, this is the initiative that was created by ISOC to basically provide crucial fixes to reduce the common elements. So, as I said, BGP is based on an inherent trust system. I trust you, you trust me, etc. We exchange routes, but there's no validation, and the trust chain, it does span the globe. So there's also a lack of reliable consistency in regards to the data on a route, i.e. its origin. Routes can be originated by multiple different ASs all at the same time. So there's a number of issues that come with how do you actually test and trust that that's actually valid. So as I mentioned, there can be situations where where an attack on the routing table, either be it deliberate or a fat-fingered typo, i.e. someone's made a mistake, can lead to some pretty significant issues. So, you know, Pakistan knocking out YouTube, large-scale BGP, hijack of India, route leaks, takes down Google, those sorts of things. There are lots of different ones that have occurred over the years, and these are just some from a couple of years ago. So what if I told you that the library has everything you need, the repositories of information? So IRR, most of you should be well and truly aware of IRR and the fact that you can go and look at the Internet Routing Registry and see a whole number of different information, a whole range of data relating to every entity that announces routes on the world. There's also RADDB. You can query it and see what the AS sets are. And you can see here, for example, I've shown you an example of AS7575. And so this is showing all of the member ASNs that are connected underneath that AS set. You can also look at like the RPKPI validator at right, for example, and you can actually go and see whether or not a route is invalid. Now, I will say that this particular web page is actually very old. It's now changed. It now shows you a picture of Routinator and gives you the same information, but it does confirm whether or not a route is invalid or not. Peering DB, I can't stress this enough. If you are looking at providing data to the internet, you really should be on Peering DB. You should be putting your routes, your information, how to be contacted, where's your looking glass, do you have any specific policies, what are your peering points and so forth. You should be putting them into Peering DB. And a lot of you do, but some of you don't. And it's probably worthwhile just going through and actually making sure that you have your data in there and it's got current and correct information. So preventing the propagation of incorrect routing information. As I've said here, one does simply not walk into Mordor. One uses Google Maps that tells you how there are 3 different buses to get there. So with this, I'll give you an example of a routing hijack. In this particular case, it was the 2008 YouTube hijack. And you can see here how what happened was that an attacker advertised a slightly, and in this case, the information behind here is not clear because it's not actually real world IPs, but just to show the example, basically the attacker announced a more specific path and the internet, generally speaking, didn't listen to it because they were going, hey, we'll filter that out. We're not gonna accept that. However, an ISP that wasn't using the appropriate filters actually did accept the route and traffic was hijacked. So this is where having strong filtering policies in your network using prefix lists, RPSL, route validation, making sure you've got routes that are signed for origin authorization, AS path filtering and so forth is really important that you make sure that you have that in place and working. So why does AARNet care? Well, this is something pretty significant from my perspective. Back in 2018, we had one of our clients who had a /16, which was being announced by us to the world and was happily working along and everything was good. And then one day it suddenly just stopped working for the customer because they couldn't access Google. We went, that's really weird. That's a bit strange. So the customer reached out to ARNet and said, what's going on? And so we started investigating. Now, ARNet did its traditional, process of looking up what's actually occurring and what's going on. We went and looked at the world routing table and went, yeah, everyone's saying it. The traffic's going to ARNet. But at this time, you couldn't actually query what Google thought of the internet unless you had a machine inside of the Google infrastructure, which this was just before Google Cloud Compute came online. So we got in touch with Google through their network surveillance team, and we said, hey, what's going on here? We've got a customer and their traffic to you is not working. We'd been checking via NetFlow that we were sending traffic to Google, but we just weren't receiving anything back for them. In this particular case, Google then a few hours later advised that they were actually seeing our client /16 from a ISP in the US who had a direct connection to Google. And so Google said, oh, based on BGP path selection, it's a shorter AS path, it's the same route length, we're going to accept that route. And so they did. This resulted in Google sending our customers' return traffic to the US ISP rather than to us. Now, luckily in this particular instance, we were able to contact the ISP in the US and ask them to cease announcing the route, which they did, and it restored connectivity to our client. Now, the thing that's important to understand here is that we may have actually had to have waited a lot longer to restore our customers' traffic had the ISP not responded to us. Now, in this particular case, the ISP was responsive and said, yes, we'll absolutely get in touch and work on this for you. Google, on the other hand, said they needed to spend probably another couple of hours working out whether or not they could or couldn't filter out the route to make it work for us. Now, based on this, we basically found that this was really something quite concerning in regards to the amount of times we were starting to see this occurring more and more in the industry. So one of the things that I did was I started talking with people around the industry, and I basically found out about MANRS, and I started talking to people about MANRS. And MANRS has been around since 2014. And with that, I basically started saying, I think ARNet should probably join MANRS. And so we reached out to MANRS and started becoming a member of MANRS. So with that, part of this was, okay, well, you've got to comply with all these various aspects of MANRS and what are the rules and so forth. So one of the things that ARNet does and has done for a very long time is we try to prevent spoofed traffic. We do this via a number of different ways, but within the MANRS process, there's an action for this. You don't have to, it's an optional, it's not a mandatory action that you must do. But within this, you must actually try and stop any spoofed packets from occurring within your network. Now, with this, the way ARNet does this is we have an ACL on our interfaces that allows the customer to send traffic from source IP addresses that we know. Now, we build this filter based on our RPSL data, and we use that to say, okay, we know that the interface has this IP address and it has the following routes behind it, therefore we'll only accept these traffic sources. And that's how we stop the customers from spoofing traffic across our network. Some of you might use URPF in a loose or a strict mode. There are options available to do that, but that's one of the key functions that we actually do. So why is this important? It's important because of the fact that we see so many times, and I'm sure many of you have experienced this, DNS amplification attacks, NTP amplification attacks, a number of different attacks where people pretend to be someone else and they send a query to an open resolver. In this particular case, I'm using the DNS example on screen. And by sending 64 bytes, you can actually get the open resolver to send 3,876 bytes to the victim. So you, in essence, DOS the victim by doing very little traffic on your side, but getting lots of traffic back towards the victim. So the fix to stop this is to use things like ACLs, URPF, and other activities to actually stop people from doing this. So there's a number of different ways you can test whether or not you're doing this. In this particular case, you can use the spoofer tool that Cada produced many years ago. I would highly recommend that you don't just put it on your laptop and test your office network. Go out to your customers' networks, try it in their networks, see what it does, and make sure that you've got the right filters in place. Again, use automation where possible to make sure that all your interfaces stop spoofing, not just some of the interfaces. If you look back here, you can see spoofing by country. This was taken a long time ago, but it gives you an idea of how where a lot of the spoofing occurred from. Now, I haven't updated this particular page in a year or two, but it gives you an idea that there's a lot of spoofing that still occurs in a number of countries. So one of the other aspects of MANRS is facilitation of global operational communication and coordination, i.e., can we actually talk to you? How do we talk to you? Is your WHOIS data up to date? Is your IRR data up to date? Have you checked your abuse contacts? As I mentioned before, have you got a peering DB page with a contact detail on it? Have you got details in the internet routing registries, RADDB, Merit, APAN, APNIC, ARIN, etc.? You know, have you got all of these configured? Have you made sure that you have got everything in your actual system ready to go, and that you've made it so that it's possible for everyone to actually reach out and talk to you if something's actually occurring? You've got to understand that this is not just, oh, Warwick needs to do this. But for everyone's security to be uplifted, all of you need to uplift this, because it's all based on the lowest common denominator. If I don't have a good line of contact between yourself and myself, I can't resolve a problem. But imagine if there are 3 or 4 ASNs between us and you that are in the path. Like, you need to be able to reach and go through the chain and actually go, how do I actually raise the bar on this? So the next part is facilitating the validation of routing information at a global scale. Now, if you look at MANRS, MANRS has a couple of different ways in which you can do this. One, you can do this via ROAs, and the other is via having your routing policies globally available and visible. So ROAs are very important because, as I've mentioned here, in 2019, we saw that AT&T started dropping invalid routes across their network. Now, this has become a lot more prevalent in the last couple of years with COVID and everything else. We've seen an uplift in the number of providers that are now dropping AS traffic based on invalid prefixes with a ROA attached. So one of the things that I would highly recommend is you make sure that you have ROAs created for your networks. So I'm going to use some examples now. Again, this API that I'm using here, unfortunately, just went away a little while ago, but there'll be some more comments about where you can get this later on. You can see here that I was checking to see, is the route validation actually successful? And in this particular case, it was. But there are other tools you can use, such as ROA stats at MANRS, or you can also use the validator within Routinator and other tools, for example. Again, just showing here that I was doing some tests, and you can see here that I had a /24 Now this /24 actually resides within a /16 that ARNet owns. Now, I deliberately put a rower in that said the origin AS was going to be 7570, which is one of our other ASNs. In this particular case, you can see here that the rower validation failed because the origin AS was wrong, and it was expected to come from 7575, sorry. And so because I had announced it as 7570 in the test lab, this showed up as being incorrect. So there are other tools that you can utilize to see whether or not your network or your upstream's network is doing the right thing. You can actually do some tests, and you can actually see whether or not your upstream is dropping invalid routes if you are on a network that is solely behind one provider. If you're behind multiple providers, this test is a little bit harder to do because you need to make sure that the path you're using is going through which particular provider to see whether or not that provider is actually doing route validation. As I said, we all have to work together. There are many different things that we all can do. We've been talking about APAN55 over the last couple of days. Going through and actually cleaning up your data and actually making sure your data is actually up to date. Making sure that, you know, if there is a need to have a route in the IRR and within rowers and so forth, do you really need to have those routes as /24s, or could you announce it as a /16 depending on the size of your network block and be more precise and concise with it? But you've got to remember that the more that you automate these things, the less likely you are to have incidents per se. However, that doesn't stop you from having fat fingers within your automation and causing problems. And we've seen that in the last couple of years, where someone has made a typo within an automated system, and that automated system then published that to the world, which resulted in a large blast radius. So again, there's a balance between automation and manual control, but at the same time, a lot of these particular aspects will help you when you're actually looking at how do you protect your customers and yourselves from the likelihood of BGP hijacks and leaks. So as I've mentioned here, there are no excuses. You should join MANRS. We do put you through a robust process in which to actually see what you're actually doing and making sure that you're following through with the right type of policies and procedures and so forth. But the other thing that I would add, you need to not only just look at it from the perspective of how you go about it, but you also need to just take into account that MANRS is something that's constantly changing. MANRS is something that you don't just do once and you look and you go, oh, that's fantastic. I've got everything I need to do. I'm good to go. There's a number of different attributes that you need to do, and you need to go and check regularly whether or not they're actually going to impact you or not. That I just want to highlight that things constantly change and you need to be aware of it. So what I'm going to do is I'm just going to show you a couple of pages and run through some things and go from there. So with that, what I was going to show you is the MANRS web page itself. You can see here I've gone to the network operators actions, and I just want to talk through, as I mentioned before, there's a whole raft of data here that you can actually read through, and there's also some guides to explain how you should do things. But again, as I mentioned before, things that you should be doing, you should be preventing the propagation of incorrect routing information. You'll notice that the order changes here because some are mandatory and some are not. You should facilitate the global operation, communication, and coordination. As I said, keeping your data up to date. There's a lot of different tools you can use. Facilitating routing on a global scale, IRR, or you could do APAN55. There's a lot of options there. And again, there's the spoofing. And then what I wanted to show you is observatory. Just out of curiosity, who here has actually seen observatory in action before? Just raise your hands if you have. Okay, so this is MANRS Observatory. Hopefully you can see this. Is this readable or is this too small for you to read at the moment? Would it help if I make it a bit bigger? Okay, so now you can go to observatory.manrs.org and you can go and actually have a look and you can see what it's showing you for all the various different times and so forth. Now, within the webpage here, you'll notice that there's an overview of routing security and so forth. Now, what I will point out to you is that this overview shows you the general internet's view versus actually looking at your individual view. So if you look here in the month of March 2023 so far, according to us, as in according to MANRS, there have been 278 routing misoriginations. There have been 45 route leaks, 666 bogon announcements. So there's a number of bits and pieces here, and there's some details that you can get later on if you are able to log in as a member of MANRS. It has identified that there, out of the 989 incidents, there were 756 culprits. So that's individuals, number of networks that have caused at least one routing incident. And then on the right here, you can see routing completeness. You can see here that 89% of the internet routes are covered within the Internet Routing Registry's tables. So RIPE, APNIC, ARAN, RADDB, Merit, etc. And then over the right, you can see here the routing completeness RPKPI. You can see that of the world, 41% of all the known routes are valid. 57% are unknown, meaning we can't determine if they're valid or invalid. Therefore, they're marked as an unknown. And then of the remainder, 0.5% is the invalids. Now, one thing that I will point out is the number of invalids is probably a little bit confusing or misleading, because there's a number of people who have put in test ranges or test blocks to actually make sure that their networks are showing up as being valid or invalid, and they do test by deliberately putting a rower in with an invalid ASN, for example, so that they can see that it triggers. The other thing that I'll point out is that as we scroll down here, you've got this MANRS readiness page, and you can see here, on the whole, most of the internet is doing route filtering on a percentage scale-ish. You can see anti-spoofing is there. You've got different things that you can see in regards to all of this. Now, you can click on Brazil as a country, and you can see Brazil's various stats. I can click on Australia, for example, and see Australia's stats. And you can go through and you can see based on, you can break it down into regions for the routing internet registries, or you can break it down into countries and so forth. So you can see here, like APNIC, for example, has a number, but it's not a bad number. The RPKPI global validation is growing. It's not as high as it could be, but it is growing. But then you have a look at APRINIC, and you look at LACNIC, and you look at ARAN. You see that the RPKI validation is actually lower than than APNIC's. So it's, at the end of the day, it's not actually the end of the world, but we are seeing it slowly increase. You've got options here to go look at histories. So you can go and look at the history of the last year, for example, showing you what the difference was in March 2022 versus March 2023. You can also look at, what each month saw in regards to filtering or anti-spoofing and so forth. So it gives you some options to see what's going on in that regard. Now, what's really interesting is, oops, okay, sorry. I'll just have to stop sharing for a moment while I do this. Now, I'm just going to share again. So you should see here, hopefully this is loading. Can you see this page? Yes? Okay. So you can now see I've changed over to the ARNet view of MANRS. Now, ARNet's view of MANRS is a little bit different because it's about my ASN. It's what my ASN is seen doing. So AS7575. So you can see here that we're filtering. We're doing pretty well on filtering. Anti-spoofing is 100%. Coordination is 100%. IRR is 100%. RPKPI is 21%. But ARNet has all of its routes with rowers, and they're all there. The reason this number is here and seen this way is that I may own, 5 or 6 blocks of IPs. However, all of my customer routes that I announce may not have rowers there. And if I announce them as 7575, as AS7575, then that is why this number will be lower like it is here today. But that's something that you've got to note when you go looking into it. But the reason I'm showing you this is because you now have this extra bit up here, the details. So if you actually click on details, you can actually get a little bit more information, and you can start doing some interesting and fun things. So you can go down to overview and you can click on your ASN, and it's going to start loading up all of these different bits of information for you. So now you might know that these numbers, they're basically grouped based on where they sit inside of the actions and so forth, but you can see where they align. So you can see here, routes leaked by AS. No, we haven't leaked any. So I'm looking for an actual example to use here. So I'm going to utilize the incident here, and you can see here that bogon prefixes propagated by the AS. So in this particular case, the MANRS observatory tool believes that 102.219.128.0/22 is considered to be a bogon because it's not either recognized as being allocated by a RIR, or it's in a currently reserved or held status. So you can then click on the link to the right, which gives you more information to see the paths. You can then click on the paths, and you can see here that in this particular case, it's originated by this AS, passed to us by this AS, and then handed to ARNet on 7575. And the reason that's showing there is because ARNet peers with the route servers for route views and other bits and pieces, as well as RIPE. And so it's seen directly as being below ARNet. So there's a couple of things that you can do within this system to see what's going on. You can also look at, bogon ASNs. And again, you can go and have a look, and you can see ASNs that are in here that should not be in this particular case. AS1618 is not meant to be announced because it's currently in a state inside the routing internet registry that says that it's not meant to be used, but it is active on the internet, as you can see by all of these routes. So this is where this information becomes really interesting. You'll also notice that there's, as I go through up here, there's BGP stream, grip, traffic. And the reason we have that is that BGP stream is now owned by Cisco. So we have that as one data source that we check for routes. We also have the grip data, which is also another source of data to see whether or not there have been any hijacks and so forth of the data. And then we flow through, and you can see all of the other different options here. You can see spoofing, you can see has records. This allows you to see if you don't run the CADA app, we can't really tell whether or not you are or are not allowing spoofing. So it's pretty important that if you want to do that, that you please make sure you run the CADA. Again, you can see here that we have under this information here, you can see that AARNet is announcing under AS7575 directly 179 prefixes. Of those, 141 are unknown. And by unknown, that means that there is no rower to tell it whether or not to check if it's a valid or invalid route. Again, you can see here that under invalid routes, there are 0. We've changed that one that I showed as a display earlier, and that's why that's now 0. But this is the information you can get. You can download it. It's in a JSON format, so you can then parse it through your various tools. Again, as I mentioned, you can start doing comparisons to see where you stand in regards to various activities. And you can see, where you're succeeding or where you're not based on these graphs and so forth. So there's a lot of useful information here that you get once you become a member of MANRS. And with that, I'm going to stop there and see if there are any questions in the actual audience, because I think this is an opportune time to hear from you, to hear if there's any questions about what you think MANRS is or what you have concerns about with using MANRS. Any questions coming from the room? Okay, I'm going to say that I can't see anybody raising their hands or anything, so I apologize. Is there anybody who's actually, let's go with this. Who is a MANRS participant? If you are, raise your hand. All right, I see a number of you. Who here is unsure if they are a MANRS participant? Who here knows they are not a MANRS participant? Okay. Who here thinks that they will become a MANRS participant within the next 12 months? Okay. Who here doesn't see a benefit in MANRS? Does everybody actually see a benefit for MANRS? If you do, raise your hand. Okay. So, okay, thank you for the, I've also had 2 people on the Zoom put signals up to say that they also agree. So with all of that, MANRS has a number of different options available to you. As I've been talking to you, I've been mainly speaking about the fact that there's the MANRS program for the network operators. There's also a program for the content delivery networks. So the likes of Google, Facebook, Twitter. There's also peering points programs as well. So if you run a peering point, you can also become MANRS compliant there. And so we also have a program which we've just announced a little while ago, which is to do with vendors. And vendors are actually uplifting their documentation and so forth to include references to MANRS and also to the best practices that are recommended. So with that, is there anyone else that wanted to ask any questions about MANRS or ask about AARNet's particular MANRS deployment or any concerns or queries? Yes, I see a hand up in the back, I think. Yes, over in the corner. If someone could give the gentleman a microphone.
Hello, I'm Christopher Bruton from Scenic. We became a MANRS participant recently, but I don't know. Are you willing to talk about some of RNet's kind of more technical implementations? I think you mentioned earlier how you build spoofing filters, ACLs based on RPSL data. Do you think you could talk a bit more about that process? Because that's something we're trying to figure out how to do this more efficiently. Right now, our filters are just manually put in when a customer tells us what their
Yeah,
preferences
sure.
are.
I can definitely talk about that. So basically the way in which ARNet handles, so ARNet does, I'll break it into a couple of components. So there's firstly, how do we accept routes from a customer? If the customer has their own AS, we will basically set it up and say to them, okay, you've got your own AS. Do you have an AS set? Do you have an entry within a routing internet registry that contains your route sets? Or if you don't, what we'll do is we'll go and create a proxy object in RADDB for you and say that the following routes are owned by the following origin AS, and we'll call it, and you can see it in the whois data for RADDB. You can see it as a proxy object created by ARNet for a customer. And so what we do is we create that data, and inside that, we then utilize a tool most of you might be familiar with, BGP Q3 or BGP Q4, depending on where you are, an RT-config or IRR toolset. And basically what we do is we take that data and we run a query that says, okay, please tell me all of the IP blocks, be it IPv4 or IPv6. We do it in a sort of a step-by-step process, but we go, this ASN, tell me all the routes that are associated to it globally, based on IRR data. We then take that data and we go, okay, we know that, okay, great. What about all the ASNs that are downstream of it? And we pull all of the ASNs as well. And that allows us to then generate a filter that we use on our BGP session that says, we're going to use this information to allow that customer to advertise the following routes to us. We apply a number of policies to those routes. So for example, a customer might want to mark a route as not quite the best path, but the second best path for redundancy reasons, so that if there's a failure, it fails to another way to get through their network, through us to them. So we have some community tags, which you can see if you do a whois AS7575 space -h space whois.raddb.net, you'll actually get the output of our routing policy, but at the very bottom is all of our community tags that we utilize to explain what each route does and so what each tag does. So with that, we take that information, we generate our policies and we push them onto our routers, but we also run another script that takes that data and produces an ACL. And the ACL that it produces is simply a inbound ACL that says traffic from source, and the source must be one of those routes that was in the IRR data that we just queried. Plus we add the interface and link local, because you obviously don't want to break link local with IPv6, so that we can accept the traffic from their device talking to our device, and then allow their routes to actually go out to the internet. And that's how we do our route filtering for stopping them from spoofing, if that makes sense.
That does, yes, thank you. Do you automate the process kind of to periodically update and refresh how your filters are and ACLs are?
At the moment, no, we don't. We basically have not enough churn in the network to require that. Obviously, you said you were from Scenic, so with your environment, that would be a little bit different, obviously, with the number of connections and things that come on board and so forth. But in our environment, we're able to do that, and we can refresh it as needed when the customers ask. But ideally, in the future, yes, it will be one of the things that we're working on, is to make it so that it's an automated process. But at the moment, it's a manual process for us.
Right, thank you. I had another question. In the MANRS Observatory, one of the measures you showed was propagating bogon prefixes and ASNs.
Yes.
And we have this. I'm wondering if there is a best practice or a push to actually block those somehow, and what the procedure for that is, because I've thought about it a lot and I don't really see a simple and reliable way to kind of manage that aspect.
So it is challenging. MANRS recommends that you try and block bogons where possible. Now, there's a number of implications that go with that. And so the things that you need to think about is you could use, like, for example, Team Siramu's bogon data to say, here's a filter that I will simply assume is correct. Now, depending on your location, country, legislative requirements legally, you may or may not be able to utilize that. We are aware of some countries don't want to hand over the keys to the kingdom per se in regards to filtering based on that data, because they can't control that data, if that makes sense. So one of the things that, wearing my MANRS hat for a moment as the chair of MANRS, one of the things that MANRS is doing is we've reached out to the routing internet registries and said, we need to understand how you all define what is actually a bogon, because every registry has its own unique way of how it actually stores that data and information set. Because what may be a unassigned route a bogon may actually be a route that has fallen out of communication between the service provider or the owner and the routing internet registry, because a payment has been missed, or an email has been missed, or someone has left the organization and the emails have not been responded to, etc. So a lot of the bogon data that's actually in the internet is legitimate traffic for legitimate reasons. The problem being, though, is no one knows how to contact those people to actually say, hey, we need to get this back into proper data sets and making sure that it's legitimate. So one of the things that we have been talking about with MANRS is asking the routing internet registries to provide us with some form of document that tells us what their various stages of a route becoming a bogon is according to them. Because as I mentioned, every one of them is slightly unique and every one of them's a bit more challenging. So it's a challenge. I won't deny it. We sit there and we look at it and go, well, how do you actually achieve 100% on bogons? That's a very hard thing to do. It's one of those things where I wish I had a silver bullet answer to you, but some people write their own special rules that go and fetch data from the various RIRs and actually pull them together to create their own version of a bogons list. And then they use that to do filtering. But it is left somewhat to the individual organization to work out just how far they want to go. And I'll give you an example. Some of our international, I'll rephrase that. Some of the national research and education networks globally, a lot of them have legacy IP space. And so the problem being is those IP spaces have fallen out of contract with the original owners. Like you look at the original allocation of IP space, for example, there was transfers to various countries and other bits and pieces. And so sometimes those records have been lost, or there's been situations where people have moved on or retired and the details have not just been updated. So if you look at, like, I'll use APNIC as an example here. APNIC has recently made an announcement that said any of the historical legacy routes that don't have an account within APNIC, as of the 30th or the 31st of December last year, we're going to be removed from the WHOIS table unless someone actually came and showed reason that they were legitimate routes and so forth. Now, they haven't stopped them from being accepted on the internet yet, but they're doing it to try and trigger people to actually get in touch and keep their records up to date. So I suspect you'll see over the course of time, more and more routing internet registries will actually start doing that as well, to try and bring that data freshness back up to the level it needs to be, so that we all are able to actually start trusting the data again, if that makes sense.
Thank you.
Any other questions?
Hello, Warwick. This is Zhonghui Li from Tsinghua University, CERNET. And I just wonder if you have ever made some kind of issue like the misjudgment, especially for the action 2. You know, maybe later in this afternoon, I will give a talk about some manner implementation in CERNET, some consideration, especially for the action 2. You know, because for the maybe there is some special scenario in CERNET, so we might have some misjudgment on the for example the identification for the stub customer networks, and also the granularity of the fault source IP address made by the selected by the CAIDA spoofer software. Because we are lack of the full understanding on its mechanism. So actually, during our SONOC, try to implementing the MANRS actions, especially for action 2, we got, although we have been done quite a lot, but we still can see a number of rows with the red line, and we don't know why. And after we try to contact with the MANRS operation team, and they told us there might be some system issue, and they will make some adjustment, and then we got all passed, but we don't know what's the exact. And maybe in this afternoon, I will try to share some case, in our CERNET, and we want to have some helpful comments from you and all the participants regarding, especially for the action 2, the spoofing issue. Yeah.
Absolutely, and look, as I mentioned before, it is an optional, it's not a mandatory, but I do recommend people try and do it where possible. But I'll just give you some examples very quickly. Some of you might have Google caches or Facebook caches or various different Twitter caches and other bits and pieces in your network, or Akamai caches. And those systems, we know that they actually do spoof some traffic. Specifically, they, the DNS entry for their website might be their actual US address, but then they redirect it to the cache. The cache then responds with that little IP address, or sorry, with that specific IP address locally within your regional country and so forth. So there are times when it is legitimate traffic that is spoofed, but the general concept is to stop your customers from spoofing and attacking networks. So yeah, I agree with you. There's interesting parts to it, and that I'm definitely keen to hear more about your particular situation. And if anyone has any issues with actually getting certified with MANRS or whatever, please don't hesitate to reach out to me, and I can reach into the operations team at MANRS and actually say, hey, what's going on here? Can I have a look, please? I want to understand this further. So, but yes, I'm looking forward to hearing more about your particular scenario there.
Thank you.
Welcome. I'm Chen Qinghan from Tsinghua University. I just have a question. For RPKI deploying, should all RSPs should do, or just recommend the tier 1 and the tier 2 ISP to deploy RPKI? How about the small ISPs?
Sorry, can you just repeat the last bit? You broke up a little bit there. I just want to make sure I heard that correctly.
Should the small ISPs deploy RPKI too?
Oh, okay. So yeah, versus, okay. So generally speaking, it depends on how you're connected. If you're a small ISP or you're a small entity in any way, shape, or form, if you are singularly homed to an upstream, as in you've only got one connection out, and that provider is doing RPKPI, doing route object validation, there is no need for you to do it in your network. That being said, you should always have a row of your own network. However, if your entity, business, ISP, school, university, etc., has multiple paths to the internet, then it is worthwhile that you do RPKPI yourself, because you may find that one provider does do invalid route drops. You may find one of your upstreams may not actually do any drops at all, but may mark the routes as invalid. And so knowing whether or not to send the traffic at all is the question. So generally speaking, my recommendation is that for entities that have a singular uplink and their provider does have RPKPI functionalities turned on, doing route object validation, then no, there's no point. But if they are going through someone who doesn't, and they don't want to have their traffic potentially going to an invalid or a foreign entity or someone who's not meant to receive the traffic, then quite simply, yes, they should do it on their network.
Australia, that's all ISPs in Australia deploy the RPKI.
Not all, but we are getting further and further along. There's probably the biggest service provider in Australia, which is called Telstra. It turned on RPKPI route object validation probably about a year and a half ago, and it's been quite successful in doing so. We have seen a number of the large next tier down service providers also do this. One thing that's very interesting, and I'll just mention it because of what you've just reminded me of, is we have seen a situation where a vendor, a service provider has got invalid route drops configured, so it drops any invalid routes, but it has a default route to its service provider, its upstream. And so traffic, if you are an invalid route, you can still send traffic through their network and get to the next stream because they've got a default route, and the default route is not subject in their network, is not subject to the, because they have not chosen to not have a default route within their network, if that makes sense. So it's just something to be mindful of. If you do deploy a default route and you say, send all my traffic out here, if you have RPKPI route object validation turned on, that's great for anything you learn. But if you still send an invalid route traffic through their network, it will still pass to the other upstream. So just something to be mindful of. Are there any other questions?
Some examples show how they deploy their RPKI, so others can see their examples, and maybe they can find an example maybe similar to their selves, so they can observe their examples and deploy their RPKI.
So I just want to reconfirm that. So are you asking about, is there examples of how people have deployed RPKPI themselves that people could follow and utilize as a guide? Is that correct?
Yes. More examples, so people can find a similar example they can use.
Oh, absolutely. In this particular case, I would point you at APNIC and say APNIC has a really good reference that talks through deploying RPKPI, and they have some training on it as well that you can attend and do virtually or face-to-face. And it actually goes through the steps by steps to actually deploy a route validator onto your system. So build a Linux host, put a route validator on it, set up the route validator so that your route validator can be spoken to by your routers so that they can pull the appropriate table of data they need. And then how you actually configure your router, the APNIC guys have actually created a really good document that has, if you're using Cisco, here's the exact type of policy map that you need to do the following effect. Here's the Juniper version that you need to do the effect. And so they've actually really got a really great document that you can follow. And I know that a number of small universities have used that. I know a number of ISPs have used it. And it's constantly being refined and worked on as new changes to route validators come into the market. So they've been keeping it up to date with data. So that's been really useful to point people at. And maybe this afternoon, I will see if I can add that to my slide deck to just show you quickly where to find that information. Sorry, I couldn't hear that one.
Internet is a distributed systems before RTI, but after we deploy the RTI, it becomes some kind of centralized systems. So maybe there will be more problem size that will cause the internet problems.
Oh, look,
so robust.
Absolutely, it is a potential, without a doubt. But the guidance that MANRS provides today is around the best practices of today, and that's why, as I said earlier today, it's a constantly evolving document of things. You'll see a number of different aspects of what is changing in the industry coming along. For example, just like you've got DNSSEC, there's BGPSEC that's coming into a bit more visibility. There's AS path authorization, which is also potentially scoring some wins that will probably come into the equation more. So within MANRS, the program itself is just to recommend 4 major actions that do seem to make a very good difference to the environment. However, how you do those actions is left up to you as the service provider to choose your options and go forward. Like it's more about the process than it is around the technology that gets you that process, if that makes sense. So one of the things that, as I mentioned before, is like, at no point do we tell you that you must use URPF, for example. We say you can use URPF, you can use ACLs, you can use whatever system you can come up with that achieves the outcome. So with that, yeah, you're right. There are options where we may see in 2 years' time that we've created another problem. But at this point, MANRS has been around since 2014. And so far, it hasn't created any problems. It's just highlighted just how big the problem is, if that makes sense.
I have a question. Are there some measures or strategies to protect or motivate MANRS members?
Sorry, can you say the first bit again?
Are there some measures to protect or motivate MANRS members?
The motivation for people to do MANRS is more around, generally speaking, it's more around whether or not you've been impacted by an event. If you've been impacted by an event, generally speaking, you're going, oh, how do I fix this? And that probably really will bring you to looking at what are my options? What are the best community practices? How do I improve the general stability and control, let alone security of my routing table? So one of the things that MANRS tries to do is to give you some tooling and some guidance to help you do that. And that's where, as I mentioned before, the MANRS Observatory is a really very useful tool to see how you're performing in that regard. But overall, the general reason why people should look at MANRS is think about it from the perspective of, do you want someone else who is not the person you're sending the data to to actually be able to read said data in some form. Now, I could go very technical and say you're only going to see half of it because it's the initial connection and so forth at a TCP level, but imagine a UDP packet. You could fill in a UDP packet with something really, it could be a simple knock-knock joke, or it could be, some form of special research data that you don't want anyone else to actually be looking at. Now, it could be encrypted, it could not be encrypted. There's a whole raft of things that go with that. But if we just look at it from a simple point of UDP, if I learn a route that is leaked or hijacked deliberately, I could send that legitimate data stream, regardless if it's readable or not, to an entity that shouldn't get it. So at the end of the day, it comes down to, do you want that to occur or do you not want that to occur? Do you want to talk with the person you're expecting to talk to? Like, I'll use an example of, do you want to send data to Google or not to Google? Generally speaking, most of us, if we're trying to access our Google account because it's got our credit card information in it for Google Wallet or other bits and pieces, you want to know you're talking to Google. You don't want to be going to somebody else. So generally speaking, most people want to improve the routing security from that perspective, but there's no driver other than just common sense in this particular case. And maybe others have a different view, but from my perspective, the reason to do MANRS is to uplift the general security and routing stability, and go from there. But there's no incentives at this point that I'm aware of, other than I will say that a number of countries are now starting to actually request that at a government level, that any providers that provide services to them or so forth must now start complying or being aligned with the MANRS recommended best practice. So this is similar to back in the day when IPv6 first came out. A number of government entities required it as, if you want to respond to this tender, you must support IPv6. Now we're starting to see that the governments are starting to say, MANRS is an important thing. Please make sure that you're compliant with MANRS, or that you're moving towards MANRS, and show justification of why you should be allowed to answer a tender, for example. Sorry, I can't hear you at the moment.
My question is over.
No worries.
Questions are going. That's very for the excellent report, and thanks all of you for your attention and time.
Thank you very much for having me.
Oh, okay, everyone, we can take a photo here. Come on. Wait a moment. Take a photo. Thank you. Thank you.